mark your own as we go along. This first question is asking us to replace x with minus 1. So you would just replace this x here with minus 1 and then work out what the answer is. So it's 1 minus 3 times minus 1 is plus 3, and that's going to give 4. So f of minus 1 equals 4. Just saying 4 will give you a mark for that. Hopefully that was pretty straightforward. The second one is not straightforward. There's loads of information on this graph. You know it's a quadratic. You should know it's a quadratic. You also know it's a positive quadratic. It's positive x squared here because it's a U shape. From here, I'm going to use the two zeros. So minus 2, 0 and 3, 0 as they are the roots or the answers when y equals 0. So if I was solving this equation equal to 0, I'd end up with these two as my answers. The line before that, if you're working backwards, plus 2 minus 3 equals 0. If you're working backwards and then you got those two things from this. You know, when you solve a quadratic, you factorize, you get 2 brackets, and then you work out each using the null factor law. So x plus 2, x minus 3 is a way of factorizing this, and that's taken directly from the roots, the opposite signs. Because, you know, when you get to this stage of a solving, when you get to that stage, and that equals 0, you know that both of them separately equal 0, and then you find out the two zeros. That's what we're doing. So we're working backwards here. Now the problem is the zeros will be unaffected by a multiplier in front. So let's call that a. So some number in front wouldn't affect where it crosses the x-axis. Okay, so what do we do with that? A times x plus 2 times x minus 3 is equal to y. That's as much information as we have so far. Okay. So we must refer back to the diagram for further information. And we have this point. This point will help us find what a is, because we know that this point works. So let's use x is 4, y is 12. X is 4, so that's a times 4 plus 2 times 4 minus 3 is equal to 12. 4 plus 2 is 6. 6 times 1 is going to be still 6. So 6 a's are equal to 12. So a must be 2. So that's something we've got. A is 2. Okay. And we know that then if I come back to this line, I can find out b and c, because it's just a matter of multiplying out then. 2 times x plus 2, x minus 3 equals y. And I'm looking to multiply that out, and when I multiply it out, I should be able to see what a, b, and c are. I already know what a is, but we'll do it anyway. So we multiply by 2 afterwards, and then you're just unfactorizing this. X times x is x squared, plus 2x, minus 3x. So hopefully you're able to do that quite quickly to get minus x, and then multiply the final 2 to get minus 6 equals y, and then multiply in by the 2 each thing. And you get 2x squared minus 2x minus 12 equals y. And then because I found a to be 2. There can be a multiplier here because you can divide everything by 2 and you still get the same roots. So you have to be aware of that. So a is 2, we knew that already. B is minus 2 and C is minus 12. All right, not an easy. So I hope if you were struggling on that one that you didn't spend a long time with it at the start of the exam. You maybe left it and came back to it afterwards. I'll record this video and I'll put it up on YouTube if you want to go over that again. All right, so question 3. It's hard to see here, but that's an x cubed, I think. So f of x is x cubed. Take away 2. find the value of x when the function equals 25. So this equals 25. So x cubed minus 2 equals 25. Solve that. So add 2 to both sides. We end up with x cubed equals 27. And then it's the cube root of 27, which we can do on our calculator if you weren't entirely sure. We have the graph from yesterday. This was the calculator exam, yeah. So if you go into math, you can see that down here is the cube root. So press cube root 27. If you're not sure, you should know that one off by heart, but it's 3 anyway. 3 times 3 times 3. All right. So I think question 4 caused a few difficulties. This is kind of use this grid to help answer the question, and we will use this grid to help answer this. So it's just so you can visualize what they're saying here. And this is just a list of 4 transformations. Okay, most of you seem to read that and then get concerned because you weren't sure what to do. I think it was pretty clear once you started reading, well, maybe not for part 2 here, but once you started reading what you needed to do with those transformations. Okay, so find the coordinates of the image of the point 5, 1 under transformation P. Okay, so image point 5, 1. 5, 1, if you use box per box, is actually somewhere here, isn't it? That'll be 5, 1. It's kind of off the grid. The line y equal to x is the transformation P, so that's this line here. If you want to put it in, probably should have used pencil, but okay. So what will that point come when it transfers through or reflects through this line? Does anyone know?
1, 5.
It's going to be at 1, 5, 1 and up 5 here. So somewhere like that. Okay, visually, I think that makes sense to me. It's the same distance, and so what has happened there, Jaden? It's reflected over line. What's happened X and Y, Valentina? They kind of look like they switched, haven't they? Okay. All right. So that's so we can say 1, 5 here. So I've used my diagram to help me with that. Find the coordinates of the image of the point x, y in general. X, y. What will happen x and y in general under transformation P followed by transformation Q. Okay, so x, y. You can use 5, 1 again if you don't want to use x, y. So we'll just use 5, 1 and we'll use x, y. I'm just going to do two examples on the side here. 5, 1 under the P transformation, which was a reflection in that line, which we just did, was 1, 5. So what does xy become under the same one? Yx. Okay. Followed by transformation Q. So Q then is a rotation of 180 degrees about the origin. The origin 0, 0. Yeah. Okay, well, if we're not sure, that's why we have this diagram here. Let's use it. So we have 1, 5 as our example point. Let's put that on our tracing paper. This here is 0. So 180 degrees, it doesn't matter what direction. Let's just go anti-clockwise just because it's easier for me here. That's 90 degrees. And that's down here at 180 degrees. So it's down here. And that's at -1, -5. That was at -1, -5 on my diagram. So that became, with Q's transformation, -1, -5. Okay, so in general, I think it's always going to happen then that whatever signs you had here, they'll just become negative. You can see that that's the same point, it's just negative because it's complete 180 transformation. And that's what we need to do, -y, -x. Once we got that, we can put it in here. That is the transformation. So hopefully that was a bit clearer. It was a challenging way of asking that. If it was just a point, you probably could do pretty easy. But because the point had no name to it, you weren't able to do it. Yeah. Yeah, it's like a general what will always happen x and y. Okay. All right. Describe fully a single transformation equivalent to P followed by Q. So a single transformation that'll get us from P, get us from for instance, 5, 1 to minus 1, minus 5. So let's look at that. So I'm using, once again, an example point. I'm going to go back up here. So it's like this has traveled through 2 transformations to get here. Is there any way of getting from 5, 1 straight to minus 1, minus 5? So there's 5, 1. There's minus 1, minus 5. Any suggestions how I can get there straight away? A translation? Is that always going to work?
Reflect it over X.
I think there's going to be, I don't think that'll always work for every time. It won't be the same translation.
Reflect over X.
Reflect over this same line?
No. Like
This one?
Yeah.
I think that one. Yeah, reflect in this line, this diagonal line, y equal to negative x or x. So a translation will work once, but it won't work in every single case. So I know I'm using only one example, but it won't work in every single case. All the translations will be different. So it's a reflection in line y equals negative x, or you could say x equals negative y. It's the same line. Okay. Describe fully a single transformation. So this is pretty similar. Equivalent to OR followed by S. Okay. So OR is a stretch scale factor 2 with an x-axis invariant. And then S is a stretch scale factor 2 with a y. Okay. Once again, I think this is easier if you use an example point. So let's use an example point. Maybe one that I noticed on let's just use something that I know is on the diagram here. I'm just going to use 2, 1. That's just my example. 2, 1. So 2, 1, for example, under stretch OR with scale factor 2, x invariant. So x doesn't change. The y just gets twice as big, isn't it? Multiply by 2. So let's just do that first. That's OR's translation. So it's going to be 2, 2, isn't it? I think that's just multiplying the y by 2 because x is invariant. Followed by s. So s is second. So s was up here. Focus. Scale factor 2, y-axis invariant. So y doesn't change. So x changes by 2. So that's multiplied by 2, and that's multiplied by 2. So it's 4, 2. Okay. So we've gone from 2, 1 to 4, 2. 2, 1 to 4, 2. All right. Huh. So they're both kind of doubled. Anyone suggest how that could be described in a single transformation? Gabe, what did you say there? Almost. It's an enlargement, yeah. Scale factor 2. What's from what point? Center. Origin, yeah. So look at our example here. It's twice as far from this point. It's twice as far. That's just a scale factor. That point has been moved twice as far. So scale factor. So it's an enlargement. You'd start off with saying enlargement. You would say scale factor. Factor 2, center 0, 0, or center the origin. So for enlargement, you'd have to say the center. You can't just say in general if it's on a diagram. Okay. So that's why notice there's 3 marks. If there's 3 marks for a single transformation, there's usually 3 parts to it. 3 things to mark you on. So maybe if you said 2 there, where did you think that, you probably didn't read it, but where did you think the 3rd mark came from? All right, describe fully a single transformation, the equivalent of the inverse of OR, kind of undoing OR. So OR is a stretch scale factor 2 with an x-axis invariant. What is the opposite to doing that? To undo it. Jack, what'd you write? Nothing. Yeah. Yeah, it's the same thing. Yeah,
You do negative?
it's the same. So to undo it, it's a just scale factor of half instead of a scale factor of 2. So it's a reduction instead of a stretch. I think you get still the marks for stretch, but use the word reduction for getting smaller. Reduction. Maybe Miss Whittian didn't say that exactly. Scale factor half, and still an x-axis invariant. Was it x? Yeah. So it's pretty much the same. It just has to undo it. So it gets smaller. Scale factor, if it was 2 of the original, the opposite would be half. If it was 3, it'd be 1/3. If it was 4, it'd be a quarter, and so on. All right, so that was a very difficult transformations question. Yes, Jack? Well, the x-axis wasn't it or? Okay, the inverse of or, it's still, the original or was x-axis invariant. So we don't want the y to change still. Just keep it the same. All right, very difficult transformations question. I think one of the harder ones anyway. All right, on this graph, sketch. All right, so this is a absolute value function. So we've got these straight line brackets, which change anything negative, positive. All right, Burgundy, yeah. All right, so luckily enough, whoever borrowed this calculator yesterday has plotted it for us already. So you need to go and use absolute value brackets. If you're not sure where they are, go to math, go to number, and it's the first one here. ABS, press enter, and you can see them flash up here. You just fill in x squared minus 4. If you don't have a graphing calculator, you're not going to be able to do that. All right, press graph, and it comes up like this. Very nice. If you ever need to, if you can't see some of this, you probably need to go to your window and change this. A good way to have it set is from -10 up to 10 in both directions, and then change it accordingly. If it doesn't fit, you can change it. Okay, let's go back to the graph by pressing graph. All right, so it's just a matter of putting this in as is. Okay, so we need to find out though where, well, you can see it on the graph, it's at 2 and -2, these points that it just bounces at, I think. So maybe put in your scale is a good idea. Put in -1, -2, 1, 2. So here and here it bounces. Now I also need to know, oh, you can't see that. Also would need to know where it crosses the y-axis. For these kind of graphs, always put in where it crosses x-axis, y-axis. And there are the points. So how do I go about finding this top point up here? There's a couple of ways. I can, there's a few ways actually. I can trace on this, and when it gets to the top, I can just stop and write down the point. So if you press trace, I can also do it algebraically, so I'll do it both ways. Algebraically, I know that when it crosses the y-axis, what happens? Well, on the cross, the y value is 0, isn't it? Okay, you can kind of read it as well. Well, let's trace. Oh, it's already there. Someone's already done it. You can just go. You want when oh, sorry, not the y value. The x value is 0. So when we get to here, notice the way when x is 0, y is 4, and then you can keep going on and get all those points. So this, or you could have done it algebraically by letting x equal 0 here, and then y has to be. It ends up -4, but absolute value makes it +4. Okay, so 4. To sum up that, let's just do 2, 4. So that's 4. Okay, and then just generally get the shape of the graph as far as we need to go. Bounces off because it's absolute value, so it looks a bit wider than it does here, and then shoots away off. Something like that. Okay, there's 3 marks. Generally, the marks are given both correct x-axis, 1 mark, correct y-axis, 1 mark, shape of the graph, 1 mark for the 3. And it's just reading off the calculator. Write down the equation of the line of symmetry of the graph. Equation of line of symmetry of that graph. Valentina, what'd you write? Nothing? Oh, no. Kayla? Yeah, x equals 0. So where would the graph fold over? It's straight down here on the y-axis. You can't say the y-axis. You have to have the equation of the line, which is the line x equals 0. That's another name for the y-axis. It's the equation of the y-axis. All along it, x equals 0. Write down the zeros of the function. So zeros would be the roots. Kalisha, what are the zeros of this function? Where it crosses the x-axis? Or, yeah, minus 2 and 2. So these are zeros. They refer to the fact that y is 0 at those points. All right, next thing. Find the value of k when k, this is a line. This is, what type of line is that? Y is equal to k. If k is just seems to be just a number. What type of line is that, Jack? Sorry? It is definitely a linear line, but it's a horizontal line. It's no slope. So imagine y is equal to 2 is just a line that goes through 2. It's just this type of line, horizontal line, slope of 0. All right, so it has to cut through this curve 3 times. So if I just draw a random straight line that goes through, that cuts at four occasions. 1, 2, 3, 4. If I do it up here, it cuts it at 2 occasions. 1, 2. I need to find out the horizontal line that cuts it at exactly 3 occasions. Anyone suggest where that might be? Felicia? Y equals what? I didn't hear it. Feline has said it with her hands. It's 4, yeah. Here is just going to clip it there, there, and there. That's 3. So k is equal to, k must be 4, for y is equal to 4. And the next one then, find the range of values for which it crosses 4 times. Anyone suggest there the range of values for which it crosses 4 times? So you can see that 3 times here, it's twice here at where zeros is, and it seems to be everything in between those two is where it crosses 4 times. How do I say that? Jaden.
Sorry?
How do I say well, what did you say for this?
I didn't write it.
Okay. Perhaps tell me, just visually, how many, so 4 times. In general, a line here is going to cross it 4 times. 1, 2, 3, 4.
Yeah.
Where does it start and stop? So what's the first time going this way, going up? What's the first time that it crosses 4 times? -2. -2 is down here. I'm talking about the y-axis. So I'm drawing straight lines across. This doesn't touch it, doesn't touch it. All of a sudden, it touches it twice here. And then it starts touching it 4 times, 4 times, 4 times, 4 times. All these lines would go through 4 times. And then it stops 3 times here and then goes to 2. So I need to be able to describe all those lines between here and here. Jack, what would I say? What's the values for y? What can y be? It can be 0. So y can be from, you want to say from 0 up to 4. But you don't want to say 0 and 4. So you have to do greater than, less than.
Now I get what you're trying to say.
Yes, I know. I perhaps didn't describe it very well. So it cannot be equal to 4, cannot be equal to 0, because that is where it's 2 and 3. But after that, between those two, it's all 4s. Anyone get full marks in that question? Oh, I didn't think so. The graph. Okay. All right, question 6 then. Hopefully this was a slightly easier question. Maybe it was, maybe not. Draw the image of the triangle A under translation, this vector. Okay, so that's 3 to the right and down 7. 3 to the right, so let's just move a single point. Let's do this one. 1, 2, 3 to the right, down 7. 1, 2, 3, 4, 5, 6, 7. Here, I think. So that's at 5 minus 4 if you're checking your answer. And I can fill in the rest of the triangle from there. I hope that's good. Draw the image. Okay, if they don't do something like they don't say what to label it, sometimes they say label it A or B or C. Just put part A or something on it just to make sure they know which one it is. Draw the image of triangle B under a stretch, factor 3, and an x and the x bar axis invariant. Ooh.
I know how to do it.
You know how to do it?
Yeah.
Okay.
You go behind the X line.
Behind. So this is triangle B.
Yeah. And then you go with 7. 7 is the first point.
Yeah.
Then you go down to -3.
-3.
Yeah, down there. That's our next point.
Is it?
Yeah.
Anyone disagree with that?
No, nobody disagrees.
Kalisha, where would you put it? Okay.
And then it goes that way, like to negative to 1 and -3.
Okay, let's have a different opinion. Jack?
For the original triangle B,
Yeah.
we just changed 0.71 to 7.
Well, let's look at the 3 points for this triangle. I like to do the points just so there's no mistake. I just write down the points. 5, 0, 7, 0, 7, 1. There's my 3 points for that triangle. Yeah, 5, 0, 7, 0, 7, 1. All right, x back axis invariant means the x number won't change. So I can already write the 3 x numbers, 5, 7, 7. I need to multiply the y by a factor of 3. So by 3, by 3, by 3. 0 times 3 is still 0. 0 times 3 is still 0. 1 times 3, 3. So these 2 points remain the same, but this point, as Jack says, moves up to here.
Easy set up triangle.
Good on you. Answer part B. Okay,
What's the triangle on the bottom?
this one?
Oh,
That's the answer to part.
translation.
Yeah. All right, describe fully a single transformation that maps A onto B. So here onto here. Anyone suggest anything for this? Sam?
It's 90-degree rotation, I think, on 3 minus 1 origin.
Yeah, it looks like a center, not origin. Origin is 0, 0. Center transfer. Yeah, so it looks like it's rotated. So let's try get our tracing paper. Let's just trial and error it. Let's just do here. Looks like it could be around there. Let's rotate.
It's down 1.
And that misses, and it needs to move down, doesn't it? Okay, so let's do this point. Next, let's move that there, and let's do, what's that, 3 minus 1. Is that it?
Yeah.
Kind of looks like it's not, my triangle's not perfect, but I think that's it. If I drew the triangle better and lined it up better, it'd work. Yes, it is, that's it. I lined it up better that time. All right, that's it. So that's my center of rotation. So it's a rotation, definitely. Which direction did I go? I went this way. So that's clockwise. With center, what was that point? 3 minus 1. Okay, so notice 3 marks again. 1, 2, 3 points. Green? Oh, yes, sorry. Clockwise 90 degrees, I didn't say that. Yes, you would need 90 degrees, yeah. Awesome. All right, so here's a functions question. Okay. F with 3 put in it, so that's the F function with 3 put in it. Let's do this nice and sharp. 2 times 3 minus 7, so that's 6 minus 7, that's minus 1. Hopefully that was easy. F of x equals 1, so 2x minus 7 equals 1. So solve that. Add 7 to both sides. 2x is equal to 8, so x must be 4. So hopefully we all got that. Find inverse of fx, so that's where you let, there's your function, put in x's and y's, then swap x's and y's, and then solve it for y. So add 7 to both sides, and divide both sides by 2. And you get this. So hopefully that wasn't too quick, but okay. Next one. Find, so first composite function. Put g of x into f of x. So g of x is root x, and I need to put that into f of x. So f of x now with root x in instead of everywhere there's an x. This is going to be 2 root x minus 7. Stop me if I'm going too fast.
It's
Yeah.
from the question A on that page.
Yeah.
It's like the equal sign is plus down. I forgot what I mean.
Equal sign is plus.
Cross out.
Oh, here?
Yeah.
X can't be 0. Tell me why x can't be 0.
Huh?
For this, why is it saying this bit?
Yeah.
It's just saying 1 over x is a function as long as x isn't 0.
Oh.
And why can't x be 0? Because 1 divided by x is, 1 divided by 0 is,
Well, anything divided by 0.
yeah, it's undefined, isn't it? Undefined, yeah. Okay, so it's an asymptote. It's just saying there's an asymptote there. All right, so I need to solve this in the next one, equal to 5. So 2 root x minus 7 equals 5. Add 7 to both sides. 2 root x is equal to 12. Divide both sides by 2. Root x is equal to 6. Oh, root x is equal to 6. Oh, square root of x is equal to 6. What does x equal? Gabe? What's the answer here? What'd you get? Oh, you probably should have the same answer. What'd you get?
Oh no, I put it like the wrong function.
Okay. So square root of what equals 6?
17.
The square root of 17 is 6. 36. The square root of 36 is 6. 6 squared is 36, yes.
Now I get it.
Oh, it's definitely not 2 anyway. All right. Find HGF. Oh, so you have to start with fx, put it into gx, then put it into hx. Oh, so it's a triple composite function. Amazing. So fx is 2x minus 7. Put that into gx. So 2x minus 7 instead of the x in gx. What's gx? Oh, yeah. That's just the square root of 2x minus 7. And put that into hx. So 2x minus 7 in instead of x. And you get 1 over square root 2x minus 7. Hopefully that was okay. Kalisha.
How do you know GX and
They're written at the start of the question. Sorry, I was just square root x and 1 over x. They were given. Okay. All right. And next question. Question? Yeah. See, which part? The solve? This? So g of x is the square root of x from the question above. And so I need to put that into the answer to that into the fx function. So All right, find the inequality, find an inequality in terms of x for which this exists. Gabe.
I have no idea.
All right, what's illegal with 1/overs and square roots? What's not allowed? Okay, can't have 1/0, cannot be 0, and what can't you get a square root of? Minus numbers, negative numbers. So for this to work, to exist, 2x minus 7 has to be greater than 0. Because if it is 0, it'll be undefined. And if I get a negative answer out of it, I will have also an error. It's not a real number. So this is my inequality in terms of x, and I can solve that then for a final answer. That's going to be greater than positive 7, so x must be greater than 3.5, and that's it. That required you to know what is illegal, undefined, and negative square roots. So that's the answer there. Okay. Tricky final part that, I think. Moving on. All right, so another transformation. Translate t by vector minus 2, 7. So that's 2 to the left, 1, 2, up 7, up to 5 here. That's that point. It's 3 across. It's 2 down. Join. Okay, so I have that done off screen. Here it is. Should be somewhere there. Left to up 7, so that's it. Reflect triangle T in the x-axis. Okay, so that's reflecting in the x-axis. All these points must look at each other. T must look, and then this one will be upside down. Okay, that's the answer to part A. That's the answer to part B, part 1. Like that. Reflect triangle T in the line x equals minus 1. And oh no, so label the answer P. Sorry, that's P. My bad. For the first one. And reflect this triangle again in the line x equals minus 1. So x equals minus 1 is here. Let's just this line. So reflected in that moment, this point is 3 squares away, so its buddy is going to be 3 squares away over there. Still going to be the same length, and that's going to be here. It's going to be like that. Okay. Label that image Q. I will. All right. Describe fully a transformation that maps P, the two we've drawn, onto Q. I think it's a rotation, isn't it? So there's P. Where is it going to be? Is it the origin? I don't think it is. It's this line maybe somewhere. Is it that point? It is that point. So that's the point minus 1, 0. So describe fully the transformation. It's a rotation. I think it's 180 degrees. Center here. All right, it's off screen now for you. Minus 1, 0. Describe fully a transformation that maps T onto U. So T to U. Any suggestions for T to U?
Stretch.
Stretch. Yeah. It's got bigger. Yeah. X-axis invariant. Okay, Felicia. So, well, you could look at the points. If you just draw the points, T has 2, 2, 5, 2 minus 2, 5 minus 2, and 5 minus 4. And the new points are 2 minus 4, 5 minus 4, and 5 minus 8. Okay, I've done that off screen. Here's it on screen. All right, so they've gone from there to there, there to there. X has not changed, so x-axis invariant, and all the y values have doubled. So I think Sam is correct. So it is a stretch. X-axis invariant SF for scale factor 2. Okay. Let's move along. Solve a quadratic equation. So we have 8x squared plus 2x minus 11 equal to 0. I just brought it all over to one side to start off with. Any suggestions how you'd solve this? Jack? Use the formula. Use the calculator as well. Solve is trying to find the roots. So let's show you with the calculator, which is 8x squared plus 2x minus 11. Graph. There it is. We just need to find where it crosses the x-axis. Second calc, zeros. So that's where it crosses, where y is equal to 0. Left bound, where is it? Oh, it's over here. Left bound, just bring it to the left-hand side of that. Press enter. Come down, bring it to the right-hand side. Press enter. Don't guess, just enter. And our 0 is minus 1.3 on that side. If you saw that. 3 significant figures if they haven't asked otherwise. So you can use the minus b formula if you want. I think this way might be a little bit quicker. Second trace, find the other 0. Just put your two things either side of it. Press enter, don't guess. And I get 1.005. Okay? Or use your formula. So that's, or use minus b plus or minus b squared minus 4ac. There was no instructions how you had to solve that, so you could have used anything. You won't be able to factorize because they're too difficult. All right, so question 10. Stone is thrown vertically upwards from ground level. Height of the stone. Okay, so if you got a question like this, you're going to need to sketch it on your calculator. So once again, go back to y equals, clear it. I hope you did these in Miss Whittian. 20x minus 4.9x squared. It won't have t on this calculator, so you just use x all the time. Okay, that's going off my graph. Hopefully you can see that. It's too high. So let's change my window. Let's look at the questions window. It says up to 25 here and down to -10. And it says over here to 4.5. So I think it'd be useful to change my window to the same. So x, let's just have 0 like they have, up to 4.5. And then from -10 up to 25. And then just graph that. Okay, and then you have to draw this in the next one, so you can get to there. I haven't even started the question yet. I just drew it, so I'll have it. Find the height of the stone after 1 second. Well, I don't need the calculator for that because t will be 1. So I would just put in 1 here for t and use my calculator. H is equal to 20 times 1 minus 4.9 times 1 squared. So that's 20. Take away 4.9. And that's going to give, what, 15.1? And that's that done without using the graph. That's algebraic methods. Okay, sketch this. So you just saw the diagram. Just copy this diagram in. The greatest height. I can trace it. Around there somewhere. Okay, so it looks like that's something like that. Goes through 4, I think. If you look at that point, it's 4 and drops down like that. All right, complete the statement. The maximum height of this is reached by is something when t is something. Anyone get a answer for that? The max height, it's going to be around here, isn't it? Look, that's the stones traveling that way. How do I get what that is going to be? Jack? 20.4, what'd you do? Okay.
I got 25.
25. Keisha? Same as Jack. Okay. So you know it crosses the x-axis at here and here. The maximum point, you can use the graph to do it, but don't use trace because it'll get you. You have to be absolutely certain on trace that you found the max point. Very hard to do. But I know the max point is going to be at 2 seconds. Why do I know that? Because of the nature of quadratic graphs. The highest point is going to be through the vertex. And the vertex, or the axis of symmetry, is going to be directly halfway between the two crossing points. So it's at 2. So t is going to be at 2. On the calculator, go to maximum. Left bound, move it a little bit left, enter. Right bound, move the right bound past where you know the maximum is, press enter. Don't guess. And you get 20.4. They were slightly off. 20.4. So 20.4 and 2.04. Okay. Find the length of the time stone is in the air. Is this not 4? Maybe it's not 4. So the length of time the stone is in the air, that's 0. I presume this is 4. I don't think it is actually 4. I have to find the zeros. Use the calculator again. Second calc. Find the zeros. Make sure you know. I just want to find. I'm trying to find this point here. I think it's 4, but it mightn't actually be 4. So I'm just moving the dot the other side. So I find that 0. Press enter. Oh, it's 4.08. So that's why this is 2.04. So the stone is in the air from 0 until 4.08. So 4.08 is the amount of time. So from 0 to that place, it's in the air. It's above the ground. And finally, this last one I'll do, and then I'll do the rest tomorrow. Find the length of time the stone is more than 18 meters above ground level. How would I do that? Draw in 18-meter line. So it's around here. Draw that in on your calculator. So have a second line, y is equal to 18. Graph it, and you see that line. Find this point of intersection and this point of intersection, and take away the two times. So you can, if you want to find the point of intersection, second, and go down to intersect. Same thing. Go to the left of the point you're looking at. Go to the right of the point you're looking at. I'll just do 1 point, so I know we're out of time. And so the intersection there is 1.33. So 1.34, and then find the other one. It's going to be around 2 point something, and subtract those two, and that'll be the length of time it is above. Maybe I'll just do it because you're waiting for an answer. Second calc, intersect. Bring it over there, enter, move it past the point, enter, 2.74. Subtract those two, and you get 1.4 seconds if you subtract those two. Okay, that was question. Is that the last question? Oh, no, there's a few more. All right, I'll do the other few tomorrow.